Hi, Professor. So this is mm, the assignment for making a real-world example for deterministic finite state machine, push-down automata, and context-free grammar. So the first example for my deterministic finite state machine is the traffic signal. So as in a real world scenario, there is a traffic signal uh, which transitions from green to yellow, and there is a certain wait time. Here I have taken 10 just for simplicity. Then it transitions to yellow, and from yellow to red, and here I have taken wait time 3, and from red to green, here I have taken wait time 12. So this is the state table of the finite state machine that I am using, and the same JSON format I have taken in the code. So this is the dictionary which is taking the this state table in the JSON format, and I am starting with initial state of red, uh, and the program is pretty simple. It starts with red, and I have run it for the five times, and I am noting down the time whenever the signal is changing. So first of all, I am getting the next state from the dictionary using the whatever the current state is, and the transition I get the next state, and I'm getting the weight of the state. So from weight I am getting here 10, and then I just print the current state, whatever is the current state, and the whatever is the weight and the time, current time. So I have run this for five iterations, and I have put a time dot sleep on the wait, so that it waits for the specified number of seconds, whatever is specified in the state table. So we can see that it starts with red, current state is red, and the wait time is 12. So if you see here, it was 36 at the end, the second, and it changed to green after 12 seconds, and it's 48 now. And after that, for after 10 seconds it changed to yellow, that is 48 to 58, and then after 3 seconds it changed to uh, red again, so that is again after just 3 seconds, and then it changed to green again after 12 seconds. So this way I have implemented the traffic signal in a, finite state machine. Next one is a push down automata. So push down automata, I have taken an example of credit card validation using regex. Uh, so earlier we also talked about this, and I found out that discover cards and mx cards can be validated using this criteria. So this I found in the on this website, which shows the criteria. So for American Express, it says it starts with 37 or 34 and has 15 digits, and for the for the Discover card, it starts with 6011 or 665. So I have used same in my code. So I have taken a dictionary again here, in which the starting string is s, and then its transitions are based on the regex. Like if it starts from 65 and has 16 characters, 6011, and has 16 characters, or starts from 34 and have 15 characters, and starts from 37 and have 15 characters, and this suggests that it can only have numeric values. So this is the code where first of all I am checking first of all I am iterating over all these four grammars. So in this list, uh, I have taken all these four, and for each character in the card number, I am I am checking if it is matching to this string, or if it does not match to this string, I have taken a condition that this string should convert to this should be present in this dictionary, and in that dictionary it should be present, the number in the card should be present. So it successfully evaluates the debit card number. So I have taken some, these four are valid card numbers which shows valid card number, and these two are invalid card numbers, so these two show invalid card numbers. So suppose if I add a digit to it so that it becomes invalid, so it will show not a, it is changed to not a valid number. So this evaluates the card number as expected. And the last one is the context free grammar, for which I have chosen to evaluate the arithmetic operations, very simple arithmetic operations like sum, addition, multiplication, and subtraction, division. So here also I have taken a dictionary where the operands convert to operations in the dictionary. So if it encounters a plus sign, then the operator becomes add, and the minus sign operator become subtract. So that's how it is processing the input string. But first of all, this input string is changed into a format. Is here it is being changed into a format where I am separating the operands and the operators, and then I'm creating a string which can be evaluated by a stack. So here when I iterate over that string, here I am getting, calling this function and getting the converted string. And here when I iterate over each of the uh, characters of this string, I get to know that if it is a integer or an operand. And if I find an operand, then I just go to this dictionary and say to perform this operation, and this dictionary uh, is like a context free grammar, so takes care of the operation and prints out the result. So here I have performed two simple operations where the result of 2 plus 7 minus 1 is 8, and the result of 3 multiplied by 8 upon 2 is 12. So if I change something here, like if I change it to 2, then the result should change. Okay, change to 7. So so this is the context free grammar. So that's all from my side. Please let me know if you have any suggestion or improvements that I should work on. Otherwise, that's my final work. Thanks.